In this video, I will perform a linear static analysis on a 3D solid using cylindrical coordinates. Full details of this exercise are on page 364 of the link PDF in the video description below. First thing I'll go ahead and do is create a directory on my desktop called problem 7. I will then start Patran. The units for this exercise are pounds, inches, and PSI. Now I'll create a new Patran database and save it to the directory I made a moment ago. I will click OK on the form on the right. Under geometry, I will define my cylindrical coordinate system using 3 points. So under type, select cylindrical. My origin will be at 0, 0, 0. My point on axis 3 will be 0 in the x, 1 in the y, and 0 in the z. And my point on the 1, 3 plane is 1 in the x, 0 in the y, and 0 in the z. I click apply. Now you see my cylindrical coordinate system here. Next, I will create 4 surfaces to define the model. So under surfaces, select the XYZ method. Here I will define a vector that will define the width, height, and depth of the surface. So the first surface will go 0.75 inches in the x, 0.5 inches in the y, and 0 inches in the z. The vector will begin at 0 in the x, 5 in the y, and 0 in the z. And then I click apply. My next surface will go 3.25, 0.5, and 0. And the point at which it will start is this point. And click apply. My next vector is 2 in the x, 0.5 in the y, and 0 in the z. And I'm using commas between the values. I'll turn on auto execute so that when I click this point, it automatically creates the surface. My next vector is 2, -5, and 0. And the point from which this vector starts is this. Let me go back to the home tab and click the front view. I will then go to the meshing tab and define my mesh seeds. I will create a uniform mesh seed consisting of 1 element for these 2 curves, 2 elements for these curves, and 4 elements for these curves. I will then select one-way bias so that I can define an L1 of 0.32 and an L2 of 0.64. From the diagram you see, depending on which way the arrow is pointing, L1 will be at the beginning and L2 will be at the end. So if I zoom in, notice the arrow is pointing this way for both of these curves. So when I select them both, L1 is here and L2 is here. For these vertical curves, my L1 is 0.25, my L2 is 0.63. For my curve list, I select these 2 curves. Now I can go to my measures and select the curve measure or the surface measure. I can select all 4 surfaces and then clicking apply. It's always a good idea after you're done meshing to run an equivalence. Next thing I want to do is make these 2-dimensional elements 3-dimensional elements. So under Fem Actions, click Sweep. Under FEA Parameters, I will leave this here for now. under mesh control, when I rotate these elements about the y-axis here, I wish to create 10 partitions. So type in 10 here. Using this coordinate frame and about the y-axis. So here under axis, select coordinate system direction 2 and select this. So this will rotate about this y-axis. If I were to select coordinate 1, it will rotate about this z-axis. But I want to rotate about this coordinate system. My sweep angle is 90 degrees. Once I do sweep these elements, I want to delete these two-dimensional elements. So check this for base entity list. Select quad, select all, then click apply. Now you'll notice that the two-dimensional elements are not here anymore. The initial elements were swept 90 degrees about this y-axis, and you can see there are 10, 1, 2, and so on. Before going on, I want to modify the nodes. So the action is modify, object is node, and method is edit. Select or check analysis and reference coordinate frame. My analysis coordinate frame will use the cylindrical coordinates, while my reference coordinate frame will use coordinate 0. So the analysis will use cylindrical coordinates, while my reference coordinate frame will use coordinate 0. So the nodes will be defined using this global coordinate system here. I simply select all the nodes, click apply, and the modification has been performed. Let me clean this. Now I can define my material under properties. I click isotropic, cause material matte. Under input properties, my Young's modulus is 10e6 psi and my Poisson ratio is 0.33. Click OK and click apply to define the material. Just as a note, if I go to home and turn on the model tree and go back to properties, I can see so far I've defined the material in the model. Now I must apply this material to the solid. So here under 3D properties, click solid, call this solid underscore prop. Under input properties, I wish to apply this material, click OK, to all of these elements. So here I will click solid element and select all. Click add, click OK, and apply. So now I've just assigned the material to the entire finite elements we have here. After this, I will go to the load BCs tab and define my various constraints. So click displacement constraint. I will create one called radial symmetry. For input data, I will restrain this from translating radially. So here 0, blank, close. My analysis coordinate frame here, make sure to select coord 1, and for the application region, select FEM here and select the 3 nodes here. Click add, OK, and apply. Now let me hide these markers. I will create a new constraint called axial symmetry. For input data, I wish to restrain it. I wish to restrain it in the axial direction. So leave the 1 place blank, comma, leave the 2 place blank, and put 0 for the third direction, which is the axial direction. Make sure analysis coordinate frame is 1. Click OK, select application region. Reorient this and select the bottom nodes. Make sure this is selected to FEM. After you've selected the bottom nodes, click Add, OK, and Apply. Uncheck this, create a new constraint called Hoop Symmetry. Under Input Data, we will restrain it, not in the 1, in the 2 we will, and not in the 3. So there's a blank entry here, followed by a comma, 0, comma, then blank. Analysis coordinate frame is 1 again. Click OK, select application region. Now to choose these nodes properly, you would do this. So here I've clicked under orientation, the front view. So I simply drag a box very slightly beyond the side of the model. Notice that it's selected just the nodes on the side. Be careful when you do this, because sometimes you may accidentally select these nodes here. Click Add, OK, and Apply. Or before that, I forgot to select the other side. So here I've selected these so far. Now let me reorient this to the top view. So now when I hover and drag a window just slightly above the edge or the side, it's just selected these nodes along this side. Click Add, OK, and Apply. So I'm done with that. Now I can define my pressure. So under the loads, BC's tab, under pressure, call this pressure. Since my elements are 3D, I can leave this as 3D. Under input data, assign a pressure of 1000 psi. Click OK. Select application region, and let me orient this so it's easier to select. Okay, now. So I've made sure I can see the backside of the model. Now here, under visible entities only, I turn that on. I get this message. Read it carefully before continuing. I simply drag a box over these elements. And if you rotate this, I have the incorrect view, so let me rotate this the other way. Now when I select these elements, you'll notice that only the ones that were immediately visible were selected. So let me go ahead and add these here. Let me view this from the top now. Let me do the same thing. Add it. And you'll see that it's only selected the ones that are immediately visible. So if I were to go here and drag a window over here, it would actually select these other ones since they were immediately visible. So nothing behind it is chosen. So you can see that nothing in the middle was chosen. Whereas if I turn this off, it would actively select elements inside of the model. So make sure this is off, click OK, and select Apply. Now let me clean this up and turn off the model tree. Now I can go to my Analysis tab and analyze my entire model. So I'll simply click Apply here. After the analysis is done, I can access my XDB results by clicking this icon and clicking apply here. Once the results are in, I can view a fringe. And I wish to review my displacements that are translational, my quantities that are x. Before that, I have to transform my results to cylindrical coordinate system. So here under plot options, I click CID and select this coordinate system, and now I click apply. So here the highest value obtained is 0.003 inches radially and negative 0.00448. When I compare this to the results, we have obtained that. Now next would be to review the axial displacement results. So here what I would do is go back to select results here. For quantity, I would change this to the Z component and hit apply. Now you can see my lowest is 0 and my highest is negative 0.004 or negative 0.04. And that is what we've obtained here. Now for the stresses. So the radial stress, here we have a maximum value of 30,000 and a minimum value of negative 38,000 psi. The same is nearly true for the hoop stress. So back in Patran, I switched the fringe result to stress tensor, quantity to the x component, and since the transformation is already there, I don't have to worry about that. So for the radial stress, the highest is 30,000 and the lowest is negative 38,000 psi. For the hoop stress, it should be the same. And for the axial stress, I get a 3,000 psi and a negative 13 psi. And if you look at the results, we're actually down a little, or we're actually off a little. So here they had 2,300 and 16,000, whereas we got 3,200 and approximately 1,400. Now I'll go ahead and clean this up. And just to show you the deformation, here I click deformation, select displacements translational, click resultant, and click apply. You'll see this may not be as clean as you would like it to be. So here under display attributes, what you can do is not show the undeformed shape by checking show undeformed, clicking apply. Now you'll notice that the green original surfaces we created are still visible. So I can go to the home tab and click erase geometry. This will just hide the geometry, it won't actually erase it. Click refresh or reset graphics, click apply here. Now if you wish to show how this is displayed, you can go to render style and switch this to shaded, click apply. Can switch between the various other options too, so depending on how you like it, you can definitely do that here. For label style, I can switch it to fixed and maybe put 7 significant figures, click apply, and notice this number change. Now if I want to show the fringe, click fringe here, say I want the stresses, the radial stresses, click apply. And now the fringe is superimposed on the deformation plot we made a moment ago. And here I can do the same thing where the label style can be changed. And here I put 11 significant figures, but you can change it to something lower. Make sure to save your work, and this concludes this example.